Welcome to right triangle trigonometry. So first let me tell you about the right triangle. The box indicates that that's a 90-degree angle, so that tells you that you have a right triangle. So any triangle with a box in it that looks like this, similar, is a right triangle. The circle with the line through it indicates theta. Theta is a degree. Let's say you have 30 degrees, 40 degrees, 50 degrees, etc. Theta represents the degree. If you don't know what the degree is, theta is the variable for a degree. And based off of theta, that's how you can tell what size of the triangle you have. So if you look directly opposite of theta, you have the opposite side of the triangle, labeled O. The line that connects the box and theta is the adjacent side of the triangle, and that's labeled A. And the diagonal line, which is also the longest side of the triangle, is labeled H for the hypotenuse. So a lot of you are familiar with the famous theorem, the Pythagorean Theorem, with these three sides of the triangle. So it would be labeled H squared is equal O squared plus A squared. H squared should always go first because it's the longest side. And based off this right triangle, you have 6 trig functions. You have sine, cosine, tangent, cosecant, secant, cotangent. Sine will be opposite over hypotenuse. These are referring to the sides of the right triangle. And if you flip sine, then that will give you the cosecant, which is hypotenuse over opposite. Cosine is adjacent over hypotenuse, which is A over H. And if you flip the cosine, you will get what's called the secant, which is H over A. Tangent will be the opposite side of the triangle divided by the adjacent side. And cotangent will be the reverse of that, which is adjacent over O. A easier way to remember this is the word Sohcahtoa. Sohcahtoa, S-O-H-C-A-H-T-O-A, stands for sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, tangent is equal to opposite over adjacent. So let's say that we have an example. They give us a triangle. They want us to label the 6 trig functions. In order to do that, you need all sides of the triangle. And if you notice, we're missing one side. So 9, when you look at 9, it's directly opposite of theta. So 9 is your opposite side of the triangle. 9 is your O. 12 is on the line that connects theta and the box. So 12 is your adjacent side. So the side we're missing would be the hypotenuse. And if we use our formula to find the missing side, we have H squared is equal to O squared, which is 9 squared, plus 12 squared. So that's 81 plus 144, 12 times 12. And when you add that up, that gives you a 225. So right now you have H squared is equal to 225. To find H, you take the square root of both sides, and that will give you H is equal to 15. So we found out what the missing side was, 15. Now if we want to find the 6 trig functions, all we do here is we plug them in. So sine of theta will be O over H, which will be 9 over 15. And when you flip that, you get what's called a cosecant of theta, which is 15 over 9. Okay, cosine of theta, that will be the A over H, which would be 12 over 15. And when you flip the cosine, you get what's called a secant. So secant of theta is 15 over 12. Tangent of theta, which will be opposite over adjacent, is going to be 9 over 12. And when you flip the tangent, you get what's called cotangent of theta, which gives you 12 over 9. So let's say they give us an example where they give us a triangle, and this triangle is a 90-degree triangle, so it's a right triangle, and our theta this time they give it to us is 37 degrees, and they just give us one side, which is 250, and they expect us to find the side labeled A. So we need to know how to calculate A. So well, we have theta, and we have what's called the adjacent side of the triangle. Remember, the adjacent side is the side that connects the line, that connects the angle, and the box is the adjacent side. And we're trying to figure out the opposite side of the triangle, because that's opposite of theta, which is 37. So we need the formula that has O and A in it. And if you notice from that chart from the previous slide, tangent is equal to opposite over adjacent. So tangent has O over A in it. So we need this. So when we plug it in, we're going to have tangent of theta, and our theta is 37 degrees, equal O, which is little a, over A, which is 250. So we're trying to solve for A. We got everything except A. So the way you solve for A is you multiply both sides by 250. What will happen is the 250s will cancel here, and you'll end up with 250 tangent 37 degrees equal A. And when you plug that into your calculator, that comes out to 188.4 if you round it. So side A is equal to 188.4. You have another formula in trig that's called a cofunction. A cofunction, you have 6 of them. First cofunction is if you have sine of theta, which is theta can be any angle, that is also equal to cosine of 90 minus theta. Likewise, if you have cosine of theta, that is equal to sine of 90 minus theta. And if you have tangent of theta is equal to cotangent 90 minus theta, and the reverse is true, which is cotangent of theta is equal to tangent of 90 minus theta. Same for cosecant and secant. So if they give you an example and they say, okay, I want the cofunction of sine of 20 degrees. So if you want the cofunction of sine of 20, the formula is you have sine of 20 is equal to cosine of 90 minus 20. So that will give you the cosine of 70. Now let's discuss a coterminal angle. A coterminal angle is any angle that is between 0 and 360, or an angle that they want in between 0 and 360. So if they give you an example, let's say they give us 1400 degrees or 1440 degrees, and they want a coterminal angle that's equivalent to that is between 0 and 360. Well, let's give a little lesson on that. So let's say we have an angle that's 30 degrees. So 0 starts always on the right x-axis, and so if we go up, we can say that this is 30 degrees here. And so if we go in a full circle from this line, that's a full 360 degrees, we have now added 360 to 30, and that gave us 390. And so that will be equal, 390 degrees is equal to 330. If you go the opposite direction, so if you start here and you come all the way back here, then you go in a negative 360. That's the negative angle. So you subtract 360 from 30, or 30 minus 360, and that gives you a negative 330. So negative 330 degrees is also equal to 30, which is also equal to 390. So basically, if you add or subtract 360, you're going to have the same angle. It's just going to be a different number. So if you want a similar angle to 1440, that's between 0 and 360, which is a coterminal angle, to get it below, you have to subtract. So in some instances, you have to subtract, and some instances, you have to add. So we have 1440 minus 360. That will give us 1080, which is still, this is equivalent to 1440, but it's still not less than 360 and bigger than 0. So we take another 360 off. And that gives us 720. That's still bigger than 360, so we take another 360 off of it, and we're at 360. So because this is less than or equal to 360, then that is our coterminal angle. So 360 degrees is equal or equivalent to 1,440 degrees. Let's say if we had a negative 20 degrees and we want to find the coterminal angle that's positive in between 0 and 360. Well, since this is negative and you want it positive, then what you would do is you would add a 360 here. And that will give you 340. So 340 degrees does lie in between 0 and 360. So this is a coterminal angle that is equivalent to 20 degrees, but is positive. Equivalent to negative 20 degrees, but is positive in between 0 and 360. Now let's convert from a radian to a degree and vice versa. So what we're going to do is we're going to take a radian and we're going to take a degree and we're going to convert from the two. So let's say that a radian we have 3 pi over 4. What does the degree look like? Well, so you may know, pi is equal to 180 degrees in trigonometry. So if you have 3 pi over 4, you really have 3 times 180 divided by 4. And so when you take 3 times 180, that will give us 540, and we divide it by 4, that comes out to 135. So 3 pi over 4 is equivalent to 135 degrees. Okay, let's say we have the degree. Let's say we have 280 degrees and we want the radian. This takes a little bit more work. What you have to do is you have to take 280 divided by 180. You always divide it by 180 when you change it from a degree to a radian. And you reduce the fraction. Well, if they both end in zeros, the zeros can be crossed out. So then we're left with 28 over 18. These are both even numbers, so what I'm going to do is divide both of them by 2, and I get 14 over 9. Because 9 is odd, 14 is even, they don't relate. Or 9 doesn't have a 2 or a 7 in it like 14 does, and 14 doesn't have a 3 in it like 9 does. So this is where you stop. So 280 degrees will convert to 14 pi over 9 radians. You stick a pi on the numerator, and so 280 degrees is equivalent to 14 pi over 9 radians.